guys, so I'm going to do a demo of our project in CPE335L or MPU lab. So our project is entitled Gas Meter with Alarm System. This measures and displays the gas concentration in ppm or parts per million of LPG and CO or carbon monoxide in the air. The system does not only display its value, but displays warning messages and rings an alarm in case of high gas levels. So this is the circuit. I'm using Arduino Uno, LCD display, 16:2, an MQ2 gas sensor, buzzer to serve as an alarm. So before I demo the different output of the meter, I'm going to explain the few important points and the code that I used in building this gas meter. So this is an MQ2 gas sensor. We bought it from Circuits Lab, an online store. I'm so sorry for the shadow. It is because of the lighting of this room. So the MQ2 gas sensor is useful for gas leakage detection for home and industry. It is suitable for detecting H2, LPG, CH4, CO, alcohol, smoke, or propane due to its high sensitivity and fast response time. Measurement can be taken as soon as possible. The sensitivity of the measure can be adjusted by the potentiometer. So you can see the potentiometer at the back of the MQ2 sensor. It has 4 pins: the VCC, ground, digital output, and the analog output. So this is what it looks like. From what I have mentioned a while ago, we choose LPG and carbon monoxide as the gas that we will measure. I will show you the spec sheet of the sensor from where I would base my codes later on. This is a sample spec sheet of the MQ2 gas sensor. So this is the graph that I will base my equation for calculating the approximate gas concentration in the air. The sensor value is based from the analog read at port A0. It is placed there, connected at the leftmost pin of the sensor. It reads integer values 0 to 1023. So we will use this value to compute for the RS over R0 or RO and get an equation from the graph from the spec sheet that I showed a while ago, and relate it to RS over RO to get the approximate gas concentration. So this is the first part of the codes that we would be using. I would show it to you. And I got this code online from one of the manufacturers of the MQ2 gas sensor. In this code, we will measure the RS or RO to be used in the next code that we would be using. So we declared values here and sample it 100 times to get the approximate value. So we click the serial monitor. Here is the serial monitor. It shows the approximate R0 value and the sensor volt. So 1.18, we have to remember that value because we will use that on the next part of the codes. So that's it. So in this code, we first declare the values to be used. Int for LPG val or value, int CO val and int buzzer pin 6. So we use the digital pin 6 for the buzzer to serve as an alarm. Okay. From the previous code, we replaced the value of R0 at the equation for the ratio of RS over R0. So now that we have the value of the RS over R0, we can now approximate the gas level in the air. We got the LPG and CO equations in ppm based on the spec sheet. So you can see there, we have the equation for LPG in ppm and CO in ppm. So the equation is based from the Excel that I made. This graph is from the spec sheet of the MQ2 gas sensor. I created an Excel to approximate the equation using the exponential or the power equation. So this is it. This is where I based my equations. Now that we have already values in ppm, the rest of the code are LCD print for the LCD displays in different situations. For LPG value less than 200, it is in normal LPG and carbon monoxide gas levels. And for CO value greater than 1000, it shows danger high CO. And for CO value greater than 10,000, it reads sensor limit. And for LPG value greater than 200, it says danger high LPG. So we have 4 different scenarios that can be displayed on the LCD. Also, an alarm would ring every time the CO or the carbon monoxide gas value is at high level. Now that I have explained the codes, we're now ready to see it in action. So how do we test this gas meter? I'm going to use a lighter. The lighter has a lighter fluid, also called as butane, a highly flammable, colorless, easily liquefied gas used in gas type lighters and butane torches. It is also called LPG, if you know it. Yeah. So the first part of the different outputs that this gas meter can produce is the normal LPG and CO. As you can see, the CO value and LPG value in ppm are now flashing. This values shows the threshold or the offset voltages of the MQ2 gas sensor. These values are still safe since it means that there are no LPG and CO in the air. So that's the first output, the normal LPG and CO. I'm going to use this lighter to change the output shown in the LCD. So now we're going to use this lighter to change the output of the LCD. So I'm going to light the lighter near the MQ2 gas sensor. Let's see if there's any changes in the LCD which shows normal LPG and CO. As you can see, danger high LPG whenever the LPG value is greater than 200 and the CO value is showing. This is This shows whenever the CO value increases 1000 ppm. As you can see and hear, the buzzer is ringing whenever the CO value is very high. So we have seen 4 different output of this gas meter. First is the normal LPG and CO, where it shows the value in ppm. The next is the danger high LPG, which shows whenever the value of the LPG is greater than 200. The next is danger high CO, whenever the CO value increases 1000. And lastly, the sensor limit whenever the CO value increases 10,000. I program it that way because the MQ2 gas sensor can only measure up to 10,000 ppm. That's why values greater than 10,000 ppm are not reliable. So this project is good for home uses, but for industry, I recommend to use 2 to 3 more sensor, because using one sensor is not enough to measure the gas concentration. This meter is only the approximation of the gas concentration in the air. So that's it. We have seen 4 different output using the MQ2 gas sensor and the use of the lighter. Thank you. Hope you enjoy this. For questions and inquiries, just PM me.